Hello, I'm Himanshu Nigam from IIPS DAVV University, Indore, and here I'm presenting NAD Internal 2 solution. I've given certain points of x, x1, x2, x3 and so on, and we have given the value of function at these points. In this question, we have to find two things. One is the first derivative of this function at point x3 and the second derivative of this function at x1. Now in the solution, first we have made forward difference table which consists of the second column consists of values of x1, x2, x3, x4 and x5, and the third column consists of the value of function at these points, and then in the succeeding columns we have find del f, del 2f and so on by using the formula del fa is equals to f of a plus h minus f of a. Now using Newton-Gregory equation, which says f of a plus hu is equals to f of a plus u del fa and so on, we have first differentiated this equation with respect to u. We got this equation, and then again differentiating this equation with respect to u, we get this equation. Now in the first part of the question, we have to find f dash x3, that is f dash at 0.27. we have on putting a plus hu is equals to 0.27, we get the value of u, that is equals to 1. Now on putting these values in equation 1, that is this equation, we got the value of f dash 0.27, which is equals to 0.9650. Now in the second part of the question, in which we have asked f double dash 0.25, we got the value of u, which is equals to 0. On putting these values in equation 2, we get the value of f double dash 0.25, which is equals to minus 6.6. Now here in the next question, we have to integrate the given function and using Simpson's rule. Okay, now we know that this table consists of 10 points and Simpson's rule require an odd number of points. So here we use trapezoidal rule for the first 2 points, and then we use Simpson's rule for the rest. Now Simpson's rule says that summation I equals to 1 to n minus 2 h into f of I plus 4 times f of I plus 1 plus f of I plus 2 divided by 3. Here on solving this equation and putting these values here, we get the value of s, which is equals to 3.1. Now here in the third question, we have given certain population of a city in a census taken once in 10 years, and we have to estimate the population in the years 1925, 1975 and 1985. So first, here also we make a forward difference table which consists of the years and the population in thousands. Then we have calculated del f, del 2f and so on, as we have calculated in the previous question. Now using Newton-Gregory equation, which says that f of x equals to f of 1 plus del f of 1 x minus x1 divided by h and so on, where here x minus x1 is equals to uh plus x. From this equation we have calculated u, which is equals to 0.4. Now f of 1925 will be equals to 36.7 when we put these values in this equation. Okay, now for the year 1975, which is near the end of the table, we use backward difference formula, which says that f of x is equals to f7 plus del f7 x minus x7 divided by h and so on. Thus here putting the value of x minus x7 by h, we get the value of u, which is equals to minus 0.6. Then using this formula, we can calculate the population in the year 1975, which comes to be 124.48. Now for the year 1985, which belongs to outside of the table values, so we cannot interpolate these values. If we assume a similar train if followed outside also, then in case of 1985 we can make this assumption. We get u is equals to 1985 minus 1981 divided by 10, which comes to be 0.4, Now here, the population in the year 1985 using the backward difference formula, we get 432.486. Now in the fourth question, we have given set of equations which are these, and using Gauss-Jordan method, we have to solve for x1, x2 and x3. Now here it is also asked that is row interchange necessary for the above equations? No. Row interchange is not necessary, though it is convenient. So we interchange equation 1 and equation 3. So we get the pivot element at the top, and like this, which is 4, and solving this coefficient matrix by applying operations like R2 changes to 2R2 minus R1 and R3 changes to 2R3 minus R1, we get this matrix. What our main goal is to make the lower and upper triangle to be 0, so that we can find the value of x1, x2 and x3. Now again applying the operation R3, which is changing to R3 minus 7R2, and then again we solve this matrix by making these two numbers 0, we get this following matrix. Now again applying the last operation, which is R2 changes to 12R2 minus R3, we get this matrix. On solving the above matrix, we get the following values of x1, x2 and x3, which is x1 is equals to minus 55.8 divided by 18, x2 is equals to 20 divided by 3, and x3 is equals to minus 25 divided by 9. Thank you.